Okay, so today we will see our first model. Okay, we'll work on our first model, which is simple linear regression model. Okay, simple linear regression. Why do we say regression? Because we are here to predict a number, right? We are here to predict a number. Okay, so it's a regression. Why linear? Because we are going to
Because you
use straight line to make predictions. So
have,
in last class I told you, right, we'll have various shapes, right, of geometric shapes that are used to
Mhm.
trace the data. So you take the trading data, you have the trading data, and then you're trying to trace the trading data. You're trying to see which equation, if I use, the equation will try to fit the curve, right? And if that the best fit equation becomes your,
Mhm.
the prediction result, and then you put in the x value, you get the y. So here we are going to talk about linear, where we are going to fit a straight line. Okay, we are going to fit a straight line. So straight line equation is mx plus c, or m1, because we have, okay. So this is linear because you're going to fit a straight line, and it's called simple. It's called simple because here you have only one x. So simple linear regression. Simple because we're talking about only one input variable. Of course, output is always one, right? Output is always one numeric value. Input is your is one input. Okay, if you have more than one input, we call it as multiple linear regression, MLR. Okay, and when you have one input, we say simple. So simple linear because we are trying to fit a straight line, and regression because our objective is to predict a numeric value, right? That's what we said. The regression is for numeric value. Classification, okay, is
Continue.
for, yes.
Continue.
Okay, okay. So okay, so yes, now let's look at this data. This data that you see, we have R's, okay, on one column, and you have marks here on second column too. So our objective here is to look at the R's and then predict marks. Okay.
Okay.
So we'll create our model. We're going to create our first model, which will take this input data and create a linear equation to predict the marks. So linear equation is created based on this data. So we will use, that's called training. Okay. Training is where in machine learning, okay, deep learning works different way. But for machine learning, what we do is we take the input and output data, okay, as part of training, and we trace that curve. Okay. And then in test or in predict, we try to predict what will be the output for a certain input. Okay, so
Yes.
right now we are assuming that your marks is dependent on only one factor, which is number of hours you study.
Arts.
Okay, so this is our raw data. Let's see if this works. My data doesn't work in the evenings. Okay, I think it's not working. Okay, I don't know why it happens, but evenings the raw doesn't work, but morning it works. It's taking so much more time. That means it's not working. Okay, so anyway, I have
The
this
traffic
data.
is more on that particular side. In
I'm
evening,
sorry.
like in evening, there would be more traffic on that
No, I
particular side.
don't think so, because Sridevi was able to open this. Okay,
Okay.
in our evening, that is her morning. So in her morning, she was able to open, but I was not able to open. So I don't know
Okay.
why this is the thing. But I show you the data. That this data I have downloaded on my machine, so I'm going to read it from, yeah, from locally. Otherwise, what you could have done is you could have clicked on raw and used the
Huh?
same link to read the data. Okay.
Okay.
So let's go back to our Python program, and we are going to build our first model and see how it looks like. Okay. So we're going to build our simple linear regression. We're going to build our simple linear regression. Okay. So I'm going to use pandas to read the data. I'm going to use matplotlib.pyplot to plot the graph. Okay. Okay, and then I'm going to use scikit-learn. Okay, we'll do it later. First, let's read the data and see. Okay, so to read the data, I'm going to say df equal to pd dot read CSV. Okay, so read
Yes.
CSV. Now, you could have directly given the raw link here, but since I'm not able to pick that up, I'm going to go to my local, and let me see where it is. It's in D data sets. Yeah, it's in D data set marks data. Okay, so I'm going to read from my local machine. Okay, you can give double slash or forward slash, one single forward slash. Okay, and then you say 2.marksdata.csv. This is the data set I showed you, exactly same data set. Okay.
Yes.
Okay. So once I run this, hopefully it should read this data frame. Now you want to see how many columns are there. Okay. If you want to see the list of columns, you can say here print columns are, okay, df dot columns. Okay. Now let's run this and see. Okay. So columns are, we call them as index, right? So you have R's, marks, and unnamed too, probably because that empty column has also been read. Okay, so we are going to remove it. Okay, I'll just remove those things. If you want to see how many how many rows and columns are there, we have something called as shape. Okay, so shape will tell you the shape. That means rows and columns. So df dot shape. Okay. Okay. Then you have something called as, okay, let's run this. So it says rows and columns. So it's reading 30 rows and 3 columns. Third column is blank, which anyway we'll have to remove it. Okay, we'll remove it. So we'll see how to remove that. Okay, so print shape, and then you have head. Okay, so head is like your first 5 rows. Top 5 rows are, and you can say here, I'll put a new line so that we get it in a new line, comma, df dot, head. Okay. So head will tell us first 5. Similarly, you have tail. Tail will give you last 5. Okay. By default, head will give you first 5 rows. Tail will give you, so this is the first 5 rows. Okay. If you want last 5, you can say tail. If you want, let's say 2 or 3 or 10 rows, you give the number here. If you don't give, by default, it'll give you 5. Okay. Otherwise, you mention the number, you get the first that many number of rows. So you get first 3 rows. Because I gave 3 here, it gave me first 3 rows here. That's the purpose of head. We also have something called as describe. Okay. Describe statistics. Okay. So if you want to see it, you say df dot describe. Okay. Now run it and see what does it give you. Okay. So it gives you, okay, mean, standard deviation, minimum value, 25% first quartile, median value, third quartile, and max. So describe will calculate these values for all the numeric columns by itself. Okay. So these are called as 5 metric or top 5 metric also. Okay. Count. So 30 rows. Mean of this data is 5.3. Mean of marks is 60.9.
60.9.
Standard deviation is 2.8. Here 21.9. Minimum value is 1.1 hours. Here it is 30 marks. No. Median is 4.7. Now you see mean and median. What do you say about the mean and median?
So median is the like middle value. Mean and median, we are using it for like
No, so
जो missing values
what does
होती है,
no what can you understand from this data? Okay, so see
was
here,
it mean and median?
median is 52. Okay, that means there are equal number of people on right side of 52 and equal number of people
I
on
think
left side
so.
of 52. Correct?
Hmm.
But mean is only 30. Okay, so mean is only 30 means we have more values which are on the lower side. Very few values are on the higher side. Otherwise, mean would have been higher. If median is 50, mean should also have been 50 if data was normally distributed. But that's
Yeah.
not the case. It means that data is skewed. Skewed on positive side or negative side? Positive side.
Positive side.
Okay, data is skewed on the positive side. That means you have many values with less than 50, or between 30 and 50, you have more values, okay, around 30, lower side, okay, very few values on the higher side. That's why you got a mean, a lower mean. Okay, this is rough idea, okay, about the data set that you get. And you have max is 98 and here it is 10.5. Okay, so describe will give you these statistics, so you can draw these statistics. Now we are going to draw our first plot. Okay, we say, I told you, right, EDA, exploratory data analysis. So this is part of exploratory data analysis. Okay, this is where you need to analyze the data. You can even draw the plot. Okay, to draw the plot you have to say plt dot scatter. I'm going to draw a scatter plot. So plt dot scatter, and then you say here, okay, df. Okay, no, see here, this is data, right? So you have to give your x column and y column. So what is x? You have data and the column name. So we want to put, let's say, R's on x-axis. So we'll say df of R's. You want to put marks on y-axis. So df, okay, marks on y-axis. So it's going to plot a scatter plot. It's going to give a
Okay.
scatter plot with x-axis R's and y-axis marks. Okay, let's run it and see what we get. Oops, we have to say plt.show. Okay,
Okay.
plt.show will show the graph. This is, you have to do this in editors, not required in notebooks like Jupyter Note, Colab. You don't have to do it. But if you're using VS Code, PyCharm, you have to give this plt.show. Okay, so you have to
Yeah.
say plt.show. Now it's going to plot it. Probably you're not able to see, correct?
No.
No, because I have not shared the entire screen. So let me share the entire screen and then you'll be able to see the plot here. So see, this is the
Okay.
plot,
Yeah.
which is drawn based on the data that we have provided them. Now you tell me, based on this
Okay.
data, what can you say about the scatter plot? These are part of your analysis, okay? Data analysis or EDA, okay? We haven't gone to machine learning yet. This is to understand like what kind of data we have, okay? So what does this tell you?
So we have x-axis, like how many number of hours the person is studying, they will get more marks. So
So
on
there is a
x-axis we have
positive correlation between marks and the
marks
number
and
of hours.
a number of hours.
Okay, there is a positive correlation. Okay, and what do you think? Is it strong, weak?
It is strong.
Probably around strong. Okay, not very strong, but
Yeah.
yes. Okay, it is on
Like it's in
the
positive side only.
positive side. Of course, you
Positive
can
side.
even calculate the coefficient of regression. Not regression, sorry, correlation coefficient. Okay, you can even calculate correlation coefficient of this graph. Okay, now let's turn our attention towards machine learning. So for machine learning, what is the first step?
Um, uh, data cleaning.
Data cleaning, right? But here data
Mm.
is all fine. Okay, we don't need to perform data cleaning. Then what?
Yeah. Then we have to encode the data.
Okay, we don't have to do it because
Okay, data cleaning we
that is
don't.
for categorical data, right? We don't have any categorical value. So data encoding is not required. Then
Scaling, it is perfect only.
Okay. So there's only one row. I mean, there's only one column, sorry, not row. There's only one column which goes as input, right? So there is no
Yeah.
need to do scaling here. Okay, point one. Point two, before scaling, we said that we have to do train, test, and test set,
Trans.
right? Yeah, breaking
Uh,
into train, test, and test set. Okay, so we have to do that as well. Okay, so that's the only thing required in this case. We don't have to do anything
yeah.
else. Maybe when we take multiple regression, we'll purposely take a data which will have categorical value so that we can do the other steps also. Okay, so coming back to this PLT, to our analysis, we will first create our x-axis. So what is not x-axis, x data, okay? So x data here, we have only one
Ours.
row, right? So I'm going to say
One.
df of all rows, comma, start from 0, go up to 1, right? Dot values. Your y is going to be df all rows, but only,
One.
yeah, comma, column 1, okay? That means second. Now this is how the third column that we are getting will go away, right? We are not using third column. So now you
Yeah.
have created x and y. Okay. Now after this x and y, you should be able to convert, break it into x train, x test, y train, y test. Okay. First xx, then yy.
Experience.
X train, x test, then y
Huh.
train, y test. So I'm going to say x train, comma, x test, comma, okay, y train, comma, y test equal to, okay, before that we have to import, right? So I'm going to say
Yeah.
from sklearn, okay, dot model selection, import train test split, okay, train test split. So here I'm going to use the train test split, and here I'm going to provide our x, comma, y, and percentage. So I'm going to say test size equal to 0.2. So 20% should be test size. And if you want
Test
to
size.
give random state, you can give random state. Okay, let's do the random state and then we'll remove it. Okay, actually we are not supposed to use this. This is good for building the model because it will give you same answer every time you run it. Same set of
Huh.
values will be taken for analysis, right? But if you do not have random state, it will take different values, isn't it?
Okay.
So I'm going to say random state as 1 or whatever, right? Okay. So you have broken into training set and test set. Now we have to run the algorithm.
We
Running
can do
the,
both now. So, like we can take test size as well and random state as well.
yeah. We have taken both, no?
Huh.
Random state, see, when we say 20%, right? Which
Huh.
20%, which 20% should be taken as test? Okay, so if you do not give random state, every time you run it, it will take different rows as
Okay.
random, the test size. First time you
Yeah.
run, it might take first 20%. Next time you run, it will take last 20%. Next time you run, it will take middle 20%. Next time it will take, alternate.
Mm-hmm.
Okay, so, you have no control over which values it takes as test. Okay, which is
Okay.
good. Okay, which is good actually. Okay,
Yeah.
but when you are building it, then you want to see same result every time. Okay, so that you can compare your answer with say textbook answer. Let's say you are doing something from textbook. Okay, you got different answer, textbook has a different answer. Now whether it is because of the random module or it's because you have done something different, something wrong, right? You can't compare if in random state is not there. So if random state is there, like if I take random state 1, then you will also get same result. Okay, so that way you can
Yeah.
compare your result with given result. Okay, see, if I run it here and I get 0.5 and you also get 0.5, that means you
Then
you have
we are
followed
right.
you have
Yeah.
followed the steps which I followed. But if you do not get same value, that
Same
means
answer.
yeah. But if you do not take
Then
the random state, right, then you
yeah.
don't know whether you have taken answer is different because the model is given different answer or you have done something different. So that's why for learning
Right.
purpose we use random state. But in real environment, we don't suggest. We want system to be random as possible. We want it to be random. Okay. So for testing purpose, it is good. So you have fixed train and test. Now we're going to run our model. It's called simple linear regression model. Okay. So I'm going to say from sklearn dot linear model. This has all the linear models. We are going to use today linear regression. Okay. Linear regression is our model that we're going to run. And I'm going to say regressor object equal to linear regression. We don't have to pass anything. Okay. Now you have to fit to train the data. Okay. Now train the data. Data training, you have to say here your regressor, okay, the object that we have created, dot fit. We have to tell them that, oh, learn from X train and Y train. This is input data and this is output data. So this is going to create that structure, okay, linear regression, that line we discussed other day, right? Okay.
Yeah.
Okay, that is being created by this fit. You want to see
Okay.
the the values. So here you have only one X, right? So you'll have one coefficient. So you'll have one coefficient. Okay.
Mm.
So this coefficient we have to learn. Sorry, we have to see what is the coefficient value, right? So you can say
Yeah.
output values or something like that.
Okay.
So output values, I'm going to say print. Okay, this is called coefficient. Coefficient is that mx plus c, right?
Mm-hmm.
They can say here evolve model. Okay, evolve model will give the line in the form of mx plus c. Okay, your m is called coefficient. Okay, it's also called as m, or also called as slope. Okay, this is your coefficient, and then you have the value here, coefficient value regressor dot, okay, coef. This will give us the coefficient. Okay, now you have to run this and talk about other one is constant, right? C constant, or also called as intercept. Okay, so this is called C constant. Okay, and this is going to be the regressor dot intercept. Intercept. Okay, intercept does not have underscore. It has underscore, right? Yes, intercept. So this will give us this equation here. So we get an equation. Okay, so this is from the output, of course. Oops, what happened? Line number 12. Line number 12. All rows. What happened here? DF, all rows, comma, from 0 go up to 1, right? Why did it give error?
What we do?
Right. So see,
Here,
here we are,
capital.
no, not capital. See, we are talking about number here, right? So we spoke about iLock and lock. So if you are using column name or index name, you have to give lock. If you are using number, you have to say iLock here. Okay.
Okay.
So you have to say
I
D
love
love dot. Yeah. You cannot access just like that. You have to use either ILOC or LOC, right? Since we are using the reference number like 0 column, first column, second column. So you have to use ILOC. Yes, you have to use ILOC here. This is what we have missed. So now when you run this, okay. So let's see. So this is our scatter plot. And now, so it's performing. Okay, see, this is your answer.
Coefficient
Okay,
7.4.
okay.
Constant density.
So what does it mean? It means y equal to your y equal to mx. M is 7.5. 7.5 x, okay, or you can say into x plus 20.6.
21.
Now you can easily predict, right? So if I,
Yeah.
if I know the value of
X.
x, okay, how many hours do you study? You study for 3 hours. So you study for 3 hours. So 3 into 7.5 is, say,
Plus
24. 24 plus 20, 44. So you're going to get around 44, 45, 40,
44
whatever, right?
marks.
Right.
Yeah.
So this is how our model is able to predict. Now
Okay.
we can predict this model. Now you see, I have used random state 1. So if you run it, again you get same answer, okay?
Yeah.
Okay. Now if I don't use random state 1, okay, let it run. It'll give us same 7.5 and 20.6. If I don't use random state 1, okay, it's going to take random values for training. Of course, you take random values for training, you get random values, okay? It will not be
Yeah.
very much different, but there will be slight difference for sure. It cannot be same. See, 7.67 and 20.4. There will be some difference when you do not take random state. But, okay, as I told you, for training, learning, okay, always use random state so that you can always compare the answer. Okay, so this is done. Okay, now the model has run. Now you have to make prediction, isn't it?
Yeah.
So you can make prediction on the data set that you have, or we can make the prediction on the X test that we have. So I'm going to say ypred equal to regressor dot predict. Predict what? Your X test. That's the reason we have created X test. Because now I'm saying
Okay.
model, okay, you have learned it. Now I'm going to test you how well you have done. So in testing, you are only passing the test value, X value. You're not passing the Y value, because we will compare the Y value. So in the next step, what we are going to do, we are going to create a DF called, let's say, result DF. And here we will say PD dot data frame. We'll create data frame. And in data frame, we will pass this as values are dictionaries. Okay. The dictionaries can be converted into data frame or tables, where your key will become the column header and value will become the rows.
Values will become rows.
Okay. So I'm going to say here actual. Okay. So this is the actual which is there in our system. Okay. So that is Y test, right? So actually is your Y test. And the value which model has
We have
predicted.
tested. Yeah.
Okay, the model has predicted, so we call it as predicted, and we will say this as ypred. Okay, now you can print it to see how well your model has predicted. So I'm going to say result df. Okay, let's run it and see the result. So we're going to close this. Okay. So actual value was 67, but we predicted 60.
60.
It was 79, we predicted 73.
73.
Okay. So we have all these values, but how do we make sure that, how do we know what is, see, we have multiple values, right? We have 6 values here, right? So we need one value to tell us, okay, how well our model has performed. Okay, I give you 10 tasks. Okay, you do 10 tasks. Now, but to evaluate, you have to give you one number, right? One grade or one number. Why do we say, percentage? How much passed? Okay, what was your percentage in masters? What was your percentage in bachelor's? Why do we say percentage? Because percentage is one number that will, kind of represent your entire effort, right?
Yeah.
You would have gone through, you must have read, let's say 20 papers, you have gone through 50 tests, right? So you won't be telling me all the 50 results, right? You will give me one
Right.
number which will have all your tests being represented, right?
So we
So
can take average.
yes. So again, we have discussed this when we were doing mean, median, mode, standard deviation. I told you that
Yeah.
average problem is some will be plus, some will be minus. Your net will become 0, right?
Yes.
Now see here, this has predicted less from 60 to
Less.
70. Okay.
Every
But here you see it has
where
predicted more,
more. Yeah.
right? Now, if you add them, because to take average, you have to add them, right? If you add them, your error will become, will plus will cancel minus, right?
Huh.
But I told
Huh.
you
Huh.
two mistakes does not make one correct, right?
Yes.
Here you made wrong, here also made wrong, right? So this mistake should add up, not cancel each other. Okay,
Mm.
first I made correct, I have made it more, so next time I'll make it less, it'll come minus. No, right? Everything is different, and so you want this to be there. So what we did was, we did minus, we did the square, is the exact
Huh.
same process that we followed to calculate standard deviation.
Yeah.
Okay, so standard deviation, it's not called standard deviation in model building, we call it as RMSC, root mean squared error. Okay, so we will talk about more properties in the next class. Today I'm going to talk about RMSE. So here, root mean squared error. What is error? Error is difference, right? What is
Difference.
square?
Negative.
Square the difference. Okay, after doing the
Yeah.
square, what we need to do? We have to take the mean.
Mean.
Mean means what? Divide the sum of the square by n,
And
right?
yes.
And then you take square root, because we did the square, now you do the square root. This is exactly
Okay.
the same formula as what we
Same.
did
Yeah.
for
Good.
standard deviation. Root mean squared error. It's called RMSE. And we have inbuilt metric from sklearn. So I'm going to say from sklearn, okay, import metrics, okay, and I'm going to say RMSE, okay, but we do not have formula to calculate RMSE, okay. So we need to figure, we have something called as mean squared error. We have MSE, mean squared error, okay. So we'll calculate mean squared error, and then we're going to calculate RMSE. Okay, so your mean squared error equal to matrix dot mean squared error. Okay, and here we are going to say first the y test value, and then you give y pred. I'm saying give me the difference between y test and y pred. So this will be considered as x, and this is considered as your x bar kind of, not x bar but
Yes.
xi kind of thing. Okay, so this one minus this one minus this one minus this, that's the difference. Okay, MSE, and then I have to found the root mean squared, right? So print, so this is like your variance, like
Yeah.
variance. Now root mean squared, okay, we'll say RMSE equal to, okay, your MSE into 0.5, right? This is, like your standard deviation, right? So now you say RMSE equal to RMSE, okay? Lower the RMSE, better is your process,
Okay.
okay? So lower your RMSE, better is your process, higher the RMSE. So this is like performance, okay? So I am saying your RMSE is 5.7. If you have
7.
simple linear regression, RMSE is 5.7, you take another model and RMSE is 2.1, then we say other model has performed better than
Yes.
Simple, yes. If the other RMSE is higher than this, then we say that this model has
Or
performed
that,
better than the other model.
okay.
Okay, so this is how you use simple linear regression, our first model. Okay, so we'll stop it here for today.